Alright guys, I need to clear up a previous error that was in the notes about how to do a follow-up analysis for chi-squared test for both homogeneity and independence. So let's talk about how to do those. First of all, follow-up analysis, that's still the same. We do that anytime we reject our null hypothesis, but what we need to talk about is how to do that for those other types of tests. So the problem that I'm going to use for some context here was the problem about the different surveys that were handed out. Just as a quick recap, there were surveys that were given out to 20 people each, red, blue, and then the control. And then the participants were asked to choose either a red or blue candy, depending on, and that was for their own choice. We were trying to decide, is there any sort of difference in our distributions of the candies that were picked versus the surveys that were given? And we ended up rejecting our null hypothesis when our p-value was less than our significance level in this case. So we need to figure out which of our categories had the greatest impact on our decision to reject our null hypothesis. Was it one of the candy colors or was it one of the survey colors? So let's talk about how to do that. So keep in mind what we're looking for is which one had the largest contribution to our decision to reject. In other words, which one contributed most to our chi-squared value. So let's think about how we found our chi-squared value, or would have found it. Remember, chi-squared is going to be found by taking the sum of all your observed values minus your expected values squared and then divided by your expected values. So we need to essentially figure out what those values were that we were adding up to that chi-squared value, which led to it being large enough in order to reject our null hypothesis. So let's talk about how to do that in an efficient way. A lot of this we can actually do from our matrices themselves. So if you need to, go ahead and get these typed back into your matrices. For matrix A, that's going to be my observed counts. So that's the 13, 5, 8, 7, 15, and 12. I then need to set up matrix B with my expected counts. So let me do that real quick here. That's going to be a 2 by 3 matrix. Coming back up to our problem, remember there was 26 in that first row, multiplied by 20 and then divided by the total of 60. Then we had 26 multiplied by 20. In fact, it was the same for all of them across the board, if I recall, for this problem, because it was the same counts for your surveys for each. So 26 times 20 divides 60. And then same for the second row as well. 34 times 20 divide by 60. 34 times 20 divide 60. And 34 times 20 divide 60. Okay, and that one I had a typo on. Let me fix that real quick here. 34 times 20 divided by 60. Okay, so here are our expected counts, and as we already know that they were greater than 5. So let's actually start to find some of the values for chi-squared from these. I need to take my observed values minus my expected values. So for me, the top part of that is going to be observed are in my matrix A. The expected are in my matrix B. So if I take matrix A minus matrix B, that's going to tell me what the differences are for all of those. So it looks like I had a difference of 4.3 in the first column, 3.6 in the second column, and then 0.6 in the third column. Next, what I need to do is I need to divide those by I need to square each of those values. So if I take the first one, which was 4.3 repeating, and square it, I'm going to get a total of 18.7 repeating, and then I need to still divide that by the expected for each of those. So I need to take 18.7. I'm just going to go to 2 decimal places, by the way. So 18.78 divided by my expected counts for that first cell. Remember, those are in matrix B. So in matrix B, I've got 8.67 as my expected counts. And then I need to do the same thing for the row below that. So 18.78 divided by 11.33 for that counts. And then I need to do that for each of my others as well. So if I go back in here, and if I want to re-scroll through this matrix, unfortunately I do have to take matrix A minus matrix B again. This time I need to take 0.6 repeating and square it. So 0.6 repeating and square it is going to be 0.4 repeating. So I'm going to take 0.44 divided by each of my expected counts for my middle column. And again, expected counts are in matrix B. So let's see what those were for matrix B. It was actually the same, so that'll speed things along a little bit for us. So 8.67 for the first row, 11.33 for the second. And then I need to do that one more time. So that last column of matrix A minus matrix B was actually I got those mixed. 0.6 repeating was for the last one. It was 3.6 repeating for the middle. So 3.6 repeating squared is going to be 13.4 repeating. So I guess that's an easy fix here. 13.44, 13.44. And then last was the 0.44 that I had previously divided by 8.67. And then 0.44 divided by 11.33. And now I should be able to calculate the contributions to my chi-squared from all of those. So I'm going to take 18.78 divided by 8.67 is going to be a contribution of 2.17 to the chi-squared value from that first column, first row. And then I'll repeat that for each of the others. So 18.78 divided by 11.33 is going to be 1.66 for that next one. Then I'll take 13.44 divided by 8.67 is going to be 1.55. Next, I'll do the same, divided by 11.33 is going to be 1.19. And then last, 0.44 divided by 8.67. 0.44 divided by 8.67 is going to be 0.05 for that contribution. And then last, 0.44 divided by 11.33 is 0.04 for that last contribution. Now, an easy way to check to make sure I did that correctly is if I take the sum of all of those, 2.17 plus 1.66 plus 1.55 plus 1.19 plus 0.05 plus 0.04. I should get my chi-squared value from up above, so 6.66. It was 6.65, so probably off by 100th place due to rounding. And so now I can look to see where the greatest contribution was to our decision to reject. Looks like the largest was this 2.17, which corresponds to the red candy and red survey. So it looks like the red candy and red survey contributed the most in order to reject our null hypothesis. All right, guys, so that's how you do a follow-up analysis for a chi-squared test for either homogeneity, like we saw here, or for a test for independence. It would work the same. Until next time, have a good day.